251 in your online textbook, or maybe you can see it later. We're going to be talking about something brand new. This is called logarithms, but we're going to just call it logs for short, okay? And this is on page 251. So I'm going to discuss the key concept that looks a little scary, especially because, you know, it's just variables, and I know variables, many times we don't understand what it means. So I'm just going to summarize what this key concept is saying for you. So a logarithm is the same thing as writing something in exponential notation. So this is exponential, meaning there's a base, b, so think of b for base. There is an exponent we call x. So in logarithmic form, which is the first one here, the exponent is on the outside. It's what the logarithm equals. And then the y is the answer you get after you evaluate. All right? So b for base, x is the exponent, and y is the answer you get afterwards. So I'm going to do a problem for you that is right from the textbook on page 251. It's the guided practice, the first one. So it'll make more sense once you see numbers. So it says log base of 3 of 81 equals 4. All right. So in the key concept, what it's saying is that 3 is your base. Okay. The number on the outside is your exponent. And the number that's right here next to the base is the answer you get. And that's it. That's what a logarithm is. It's another way of writing something in exponential form. Obviously, a way to check your answer is make sure it makes sense, right? Does 3 to the 4th power equal 81? Yeah, it does. All right. Also, I want to talk about something I stole from a YouTube video that I'm also going to share with you. It's called the snail method. So you know what a snail is. A snail is something that looks like this, right? I'm not the best at drawing. So here's a snail, right? So the base in this case is the head of the snail. So this 3 is the snail's head. Then we wrap around like a shell here, and we go back around. So 3 to the outside to the 4th power, and then go back to the inside equals 81. So you're going to hear me say a lot, snail. We're going to snail something, or we're going to use the snail method. That's what I mean. It means take the base, the little number, that's the head, then go back around, and that's the shell. So 3 to the 4th power equals 81 is your answer. And that's if the problem tells you to rewrite in exponential form. All right, I'm going to give you a problem now. You're going to pause the video after I write it and see if you could write this problem in exponential form. So here we go. All right, go ahead and try. All right, now that you came back, let's see how you did. So if I'm going to apply the snail method, I'm saying that this 7 is the base. I'm going to wrap around and come back around. So that would be 7 to the 1st power equals 7. And that's it. Does that make sense? Yes, it does. 7 to the 1st power is 7. So we are done. All right. Now, the next thing in the lesson is how to evaluate. So now they're not going to tell you what the problem equals. It's just, this is what the problem looks like. We have to figure out what the answer to this is. All right? So log base 4 of 64 is equal to what? So that means 4 to what power is equal to 64? So what I like to do first is I like to make an equation. All right, using the key concept and the variables they use for the key concept, notice that it equals x, right? So that's what I'm going to make this equal, x, some x. I'm looking for what the x is. So I'm going to apply the snail method. So it would be 4 to what power is equal to 64? So 4 to what power is equal to 64? X equals 3. So your answer is 3. Now, how do you do that? Well, you have to be good at your times tables or, trial and error, meaning like plug in random numbers until you get it. So 4 to the first is obviously not it. 4 to the second is obviously not it. And then just keep on trying until you get what the answer is. So X equals 3 because 4 to the third power is 64. All right, again, I'm going to now give you one and see if you could do it. So pause the video and see if you could evaluate that. Now that you've come back, let's see how you did. So I equal it to X. I'm use the snail method and I'm saying 5 to what power is equal to 25? That's easy. That's 2. So your answer is 2. Now, the last thing, before I talk about the last thing, I'm going to do problems that are a little bit more challenging in the textbook. And this requires you to have prior knowledge about rational exponents and negative exponents. So, for example, ouch, just hit myself. Log base of 36 of 6. So set it up. Equals X, right? And now do the snail. So that would be 36 to what power is 6? So now when you take a look at this, this is you're probably thinking to yourself, well, wait a second. If I put a number in there for X, 36 is just going to get bigger. How am I going to equal that to 6? How am I going to make it a number that's smaller than the base? So this is where you have to think about always think to yourself, what is the relationship? Is this, meaning 36 and 6, what relationship do they share? Well, I know that 6 is the square root. 6 is the square root of 36. So now I have to think in exponents. How do I write a square root as an exponent? Think of something you learned early in chapter 3. So this would be the 1/2 power, because if you remember, the denominator is the root. So 36 to the 1/2 power equals 6. So your answer is just 1/2. All right. So you're gonna have challenges come up when your base is bigger, obviously. All right, so I'll do one more challenging one with you, and this is a fraction base. So this is also in your textbook. I'm looking on the top of page 252. So this one says log base of 1/5, of 125. So again, set it up. Use the snail. So we're saying 1/5 to what power is equal to 125? So when you get a problem that's challenging, again, think of what is the relationship. So 1/5 and 125. Well, I know that 5 to the third power is 125, but this is clearly not a 5, but I do know that it's the reciprocal of 5. So what in exponents makes something turn into a reciprocal? That would be a negative exponent. So instead of 3 being your answer is -3, because -3, 1/5 to the -3 power is 125. All right, so there you go. Those are problems that are a little bit more challenging. And the last thing in my video that I'm going to be discussing, and this only reaches to halfway through the lesson. The other half I will share another video with you. Right now we are just doing the first 2 pages of section 4.4. So you're going to see two words in highlighted. So the first one says common logarithm, which I'm just going to say I'm going to just say common log. So a common log is a log that has a base of 10. So what makes this special is that this is something you can use your calculator for. So you're not going to ever see this 10. Instead, what you're going to see is just the word log and then some number. They don't actually write the 10 there. So when you don't see the 10 in this spot and you just see a blank, that automatically means that it's base 10, and for those you can use a calculator. So what do I mean? So I'm going to say like log of 1,000. So you'll just see that problem without the base, and that's understood that that means log base of 10 of 1,000. But again, you can just take this and put it in the calculator if you don't want to think, or you can do the snail if you want. So it's saying 10 to what power equals 1,000, and that would be 3, right? Okay, so that is common log. And the last special log that exists is called the natural log. Natural log. Natural log is a logarithm with base e. And just like the common log, you're never going to see it written like this. Instead, the notation for natural log, or log of base e, which is a lesson you guys just learned, is going to be written like this. ln, not in, ln x. Okay, ln, it stands for natural log. And this is another one that your calculator can do, or any calculator in general. So for example, you'll be given a problem, ln, let's say 0.3. So what that means is log base e 0.3. So 0.3. So if we were doing this without a calculator, you would say e to what power is equal to 0.3. But that is definitely very difficult to do without a calculator. Can't figure that one out. So for these, especially for natural log, you just want to go right into the calculator and type this in. Okay, so natural log of 0.3. And that is equal to approximately, it's a never-ending number, we're going to just say negative 1.2. Okay, and that's how you would evaluate natural logs. Just use the calculator. Use the calculator whenever it is possible, because when the base is not 10 and when the base is not e, you do have to do it without a calculator because there is no button that can do those. The calculator can only do common logs and natural logs. I hope this video helped. I will talk to you guys soon.